Okay, hello guys. So first thing, just a quick announcement. The Unit 2 exam for this class will be on Tuesday, March 30th. That is, let me see, next Tuesday. I have already posted the study guide. If you go to Unit 2, you'll see Unit 2 review there. And if you click on that, you'll see the study guide in there. I haven't posted the practice problems just yet, but I probably will by the end of today, just so if you want to get a head start on studying, you can. But like always, we will have a review day on Monday before the exam. So if you didn't get a chance to complete today's check-in, please make sure you do so by 11:59 p.m. And today we're just going to go over two variable linear inequalities. Today is going to go by super quick. A lot of it is going to be a lot of review. So let us go ahead and jump right in. Let me share my other screen. Does anyone have any questions before I begin? Questions, concerns?
No, ma'am.
Okay, perfect. Okay. One second. Okay, so two variable linear inequalities. So the words we're going to look at today is solution set, which basically is the set of ordered pairs x and y that cause the inequality to be true when substituting into the inequality. So we'll see what this looks like today. So what's the difference between equations and inequalities? Well, equations often look like us using the equal sign. So whenever we use an equation, we might use it in this instance. Here it's telling us the band's rate. It says the band charges $150 per weekend show. So if it's on the weekend, they charge $150 per show. If it's on the weekday, however, they charge $50 per show. X will represent the number of weekdays and Y will represent the number of weekend shows. So here we have our equation, which is 50, so $50 for every weekday show and $150 for every weekend show. Well, we're going to look at when we need to use an equation and when we need to use an inequality. Well, we'll use an equation whenever we're asked to identify when something will be an exact amount. So, for example, if we're asked how many weekend shows and how many weekday shows do they have to perform in order to make exactly $1,500. So our equation would look like this: 50x plus 150y is equal to 1,500, right? Because whenever we get the solution to this, they have to make exactly $150, and that's an equation. So whenever we're told exactly, we use an equation. An inequality, on the other hand, is when we're asked how many weekend shows or weekday shows they have to make more than that amount or less than that amount, when we're not asked to find the exact value. So, for example, how many weekend shows and weekday shows do they have to do to make more than $150? Well, if they're making more than $150, then what we want to do is take our original equation, and that original equation needs to be greater than $1,500. Okay, so that's when we would use an inequality. Inequalities take the form of less than, greater than or equal to, or greater than, or less than or equal to. Okay, so an equation uses the equal sign. Our inequalities use all these different signs: less than, greater than, less than or equal to, greater than or equal to. So we use an inequality whenever we're asked to identify how many, in this instance, how many shows they need to make more than, and we use an equation whenever it's exactly the amount. Okay, so exactly is represented by the equal sign, more than or less than is represented by this right here. So let me just do a quick check for understanding so we know we can move on. Okay. And then just post your response in the chat box, and I'll give you 30 seconds. So this is asking which symbol represents exactly. Which of these symbols represents exactly? And in the chat box, you should put A, B, C, or D. Just in the chat box. A, B, C, or D. Which symbol represents exactly? Yes. So everybody got that right. Exactly is represented by that equal sign. That would represent exactly. Okay. Wonderful. Let me go back and share my screen. So we use an equation when we're looking for the exact amount, and we use the inequality when we're looking for greater than a certain amount, less than a certain amount, greater than or equal to a certain amount, etc. Good job. Okay, so now we're going to look at solution set, which was our word of the day. And this, again, the solution set of an inequality is the set of ordered pairs x and y that make the inequality true. For example, here we're told the band plays 6 weekdays and 5 weekend shows. Do they meet their goal of making more than $150? Well, if we're looking for them making their goal of more than $150, because we're using the term more than, we know that we want to use an inequality, right? It doesn't say exactly $150, but it's saying more than. So we use the equation that we created for more than. I keep saying $150, $1,500, sorry guys. So our solution set is basically the ordered pair that we're gonna plug into this. So we saw X represents the number of weekdays and Y represents the number of weekends. Here we're told that this band plays 6 weekdays and 5 weekends. So that would give us our ordered pairs, X and Y. Right, 6 weekdays, 5 weekend shows. So now what we can do is we can plug this set into our inequality here and see if it is true. So 50, X is 6, plus 150, Y is 5, and we want that to be more than 1,500. Okay, 50 times 6 is 300. 150 times 5 is 750. And we want to make sure that that is more than 1,500. So when I add those together, I get 1,050, 1,500. And what I'll realize is that 1,050 is not greater than 1,500. So that means that if they performed 6 weekdays and 5 weekends, they would not meet their goal of making more than $1,500. So the band did not meet their goal of making more than, right? Because we want it to be more than $1,500, right? They made less than that. They made 1,050. Okay, so basically the solution set allows us to plug in our solution, our X and Y's, into our inequality to solve to see if that is an accurate solution to our inequality. All right. So now we're going to look at graphing inequalities, and we can graph inequalities in a number line or in a coordinate grid. But before we do that, I just want to do a quick review of what inequalities mean. So say I have something y is greater than 5. Well, I know this is telling me y is greater than 5 because this symbol, if you think of it as an alligator, it always eats the larger amount. So this is saying y is greater than 5. If it was like this would be y is less than 5, and I know it's less than 5 because the alligator always eats the larger amount. So 5 in this instance would be the larger amount. So this is y is greater than 5. And this is y is less than 5. Right? Because the alligator always eats the bigger amount. So what if I have y is greater than or equal to 5? Well, again, this symbol tells me that y is greater than 5. But this symbol right here tells me it can also be equal to 5. So it can also be 5, or it can be a number greater than 5. So this is telling me y is greater than or equal to 5. Okay? What if I had it this way? Well, as I can see here, the alligator is facing the 5, which means 5 is my greater amount, which means y is less than 5. But it's telling me y is less than or greater to 5. Because that tells me or equal to. Sorry, or equal to. Less than or equal to 5. So y is less than or equal to 5. Okay, so this first symbol tells me y is greater than. This one tells me y is less than. This one tells me y is greater than or equal to. And this one tells me y is less than or equal to. Okay, and this is important because we're going to deal with these in just a second. So I want to do a quick check for understanding. Super quick. Let's see. Not that one, this one. Okay, again, just put your response in the chat box. This one's asking, which equation represents y is more than 1 or greater than 1? Y is greater than 1. Oh, I just realized that that started halfway. Okay, I'll move it right there. Okay. Y is more than 1. So yes, you guys are correct. A would represent y is greater than 1 because the alligator is eating the greater amount, y. This one is y is less than 1. This is y is equal to 1. And this is y is greater than or equal to 1. So good job. A would be our answer. Okay, now let's go back. Okay, now we're going to look at how to graph inequalities. One second. Okay, how to graph inequalities. So we can graph inequalities on a number line, or we can graph them on a coordinate grid. And so on a number line, here we have our number line, and here we have an example that says y is, this is facing the -1, so y is less than -1, that's what that's telling me. And so I can graph that on a number line by using a open circle. I use an open circle because it is less than. I use an open circle when I see the symbols less than or greater than. And I use a closed circle whenever I see less than or equal to or greater than or equal to. okay? The reason I use an open circle when I don't have or equal to is because that number is not included in that set, right? It has to be greater than. I use a closed circle when it says is equal to because that number would be included to that set because that number could be equal to that number, so that number would be included. But here, because I have a symbol that looks like this, I know to use an open circle, so I use an open circle. And then I draw my number line to include all those values which are less than -1. And so all these values here are less than -1. So that's how I would create this number line. Now, what about a coordinate plane? Well, very similar to how we created the number line, the way you create your coordinate plane is very important. And so the important thing is having a dashed or a solid line. So we'll have a dashed line whenever we see greater than or less than. And we'll have a solid line whenever we see greater than or equal to or less than or equal to. So whenever we see these symbols that represent or equal to, that's when we know to use a solid line. And so because we, in this instance, see this symbol being used, we know we need to use a dashed line. And so that's why you see this line being used, which represents that dashed line. Okay? And again, this is saying the same thing. Y is less than -1. So if y is less than -1, then we would include all the y values which are less than -1. So -2, -3, -4, -5, -6. All those y values that extend this way are y values which are less than -1. So that is why we would create our graph to look like this. But the importance here is to know when to use a dashed line and when to use a solid line. We use a dashed line whenever we don't have or equal to. But whenever we see or equal to, we want to use a solid line. That's the first step when creating a coordinate plane to represent our inequalities. So let me just do a quick check for understanding again, because this is the most important part. Okay. Here's our check for understanding. Okay. Hope that doesn't show up like that on your side of the screen. Give me 1 second to make sure. Okay, yeah. Okay, so in the chat box, put your response. The line of the function y is greater than 2x plus 3 is a solid line or a dashed line. What type of symbol do we see, and what does that mean? We have a solid line or a dashed line? We have a solid line or a dashed line, A or B? So yes, good job. So in this instance, we have a dashed line because we see here a greater than symbol. If we saw a less than symbol, we'd also have a dashed line. But because we don't see or equal to, we know we have to use a dashed line, not a solid line. Okay. How about this one? The line of function y is greater than or equal to 5x is a solid line or a dashed line. What does this symbol tell us? Do we have a solid or a dashed line? And again, just put your response in the chat box. Solid or dashed line. Perfect. So yes, in this one, we would use a solid line because we see that or equal to. Whenever we see that or equal to, we know we need to use a solid line. Good job. Okay. All right. There we go. Almost done. Okay. So now we're actually going to see two variable linear inequalities being graphed on a coordinate plane. So same thing. If we see or equal to, we know to use solid. So if you see something that represents or equal to this one or this one, use a solid line. If you see something that just says greater than or equal to, less than or greater than, then use a dashed line. Right? So if you see this symbol right here, that's a giveaway that you need a solid line. Okay, so here we have this equation right here. 2x plus y is less than or equal to 4. So because we have less than or equal to 4, because we have equal to, we need to use a solid line. So here we see a solid line being used. Oh my goodness. So we know we need to use a solid line. Okay. So now we're going to get into learning how to shade using two variable linear inequalities. So how do I know to shade on this side of the coordinate grid and not on this side of the coordinate grid? How do I know which side to shade on? Well, the way that you do that is you use a solution set, and you want to see if that solution set proves this inequality to be true. If it's true, well, then we would shade that side of the solution set. Okay? So I'm going to show you what this means. So the easiest way to go about choosing which side is always to see if that line passes the origin. If that line doesn't pass the origin, then what you want to do is you want to check the 0, 0. Because that's the easiest thing to work with, right? So basically, I want to see if I plug 0, 0 into this equation right here, is it true? And if it is true, then I can shade that part of that line, so that half of that line. So for example, 2, 0 plus 0, is that going to be less than or equal to 4? Well, 2 times 0 is 0, plus 0. 0 plus 0 is 0. Okay, so I want to see, is this true? Is 0 less than or equal to 4? Yes, 0 is in fact less than 4. So that would be true, which means that I could shade on this side of my coordinate grid. Okay, so say I didn't know that that side of the coordinate grid was the green part. So say I wanted to test this coordinate right here, right? This one is 5 and 5. So I want to see if that side of the coordinate grid proves this inequality to be true. If it doesn't prove that inequality to be true, then I can't shade that side of the coordinate grid. So let's test that out. So we're looking at 5 and 5. So 2, 5 plus 5. So I'm just plugging in my x and y values, right? This is my x and y values. So that's what I'm plugging in. Needs to be less than or equal to 4. So 2 times 5 is 10, plus 5, 15. Well, is this true? Is it true that 15 is less than or equal to 4? No, 15 is actually greater than 4. So that would not be true. And so that's why we can't shade on that side of the coordinate grid, right? So you want to test different coordinates depending on which side you want to test. If you want to test if this side is the side you need to shade, then you can try any coordinate on that side. If you want to test if this side is the side you need to shade, you can test any coordinate on that side. The only thing is you cannot test a coordinate that lies directly on the line. So I couldn't test this coordinate right here. Okay. If a coordinate lies directly on that line, you don't want to try it. You want to try it on as far on each side as possible. Okay. So that's why in this green section, we use 0, 0. And on this section, we use 5 and 5. Okay. Any questions about this? And we'll see some more examples tomorrow, but any questions? Okay. We can also use inequalities to find solutions. So for example, let's go back to our band. On weekdays, they charge $50 for each show. And on weekends, they charge $150 for each show. And we want to identify when they will make more than $1,500, right? So that's what we were looking for. Well, what you can actually do is you can graph this inequality. And again, we would use a dashed line. Why would we use a dashed line? Because we have this symbol right here, and it doesn't say or equal to anything. It just says that we want more than $1,500. So we use a dashed line. And then we would know which one to shade because we would test, we would test a certain coordinate. So if I wanted to see, if I could shade this side, I might use this coordinate right here, which is 30 and 10. Okay, if I want to see if I need to shade that part of my coordinate grid, then I would just plug that in. 50, 30 plus 150. 10, is that in fact greater than 1,500? Well, we can test it out. 1,500 plus 1,500. Add those together, that would be 3,000. Is 3,000 in fact less than or more than 1,500? Is 3,000 more than 1,500? Yes, that's true. So we would shade that part, and that's why that part is shaded. Okay. Okay, so that's why we shaded that part. So we have a dashed line, and we shaded that part because we tested a solution set. But what you could actually do here is you can find exactly the instance in which they would make exactly $150. And the way you would do that is you would find out when this equation and the value you're looking for intersect. So the point at which they intersect right here would tell me when that band makes exactly $1,500 if I was being asked to find that. Okay, and that point of intersection is actually 12 and 6. So if you wanted to know exactly when that band would make $1,500, it's at 12 weekday shows and 6 weekend shows, if you're being asked to solve for that, okay? So that would be the solution to this inequality. Okay, so basically what did we do today? Well, we looked at the solution set, which again, the solution set is inequality is the set of points or values that make the inequality true. So basically the X and Y values that make that inequality true. Okay, a two-variable inequality graph has a boundary line along the related function and a shaded half plane for the solution set. So again, we know to use a dashed line whenever we have greater than or less than. And we know to use a solid line whenever we have greater than or equal to or less than or equal to. And we know how to solve for which part of the set we need to shade by selecting a coordinate. We select a coordinate. If when I plug that solution set in, that X and Y value into my inequality, when I plug that solution set in, if that proves that inequality to be true, well, then I know to shade that half of the coordinate grid, okay? The way you could go ahead and solve for a solution set, you could use substitution or graphing to complete a solution set. So basically, if I wanted to find that point of intersection, I could create a graph for this part of the equation and this part of the equation and see when they intersect to solve for that, if I was asked to do so. Okay. So what type of problems might we encounter? We might be asked to write an equation representing the relationship between two variables and then complete the inequality using keywords to determine the inequality symbol. So you might ask to write an equation. You might be asked when something is exactly an amount, when something is greater than an amount, less than an amount, greater than or equal to, or less than or equal to. So you may be asked to create an equation and know what you have to know which type of inequality symbol to use. So that's the type of one problem you might encounter. The next one is you might be asked to graph a two-variable inequality, like we saw before. So we use a dashed line whenever we see these symbols, a solid line whenever we use these symbols, and then we want to test a point, not on the line, to determine how to shade the graph, okay, which we looked at today. And then lastly, you might be asked to solve a two-variable inequality given one variable. So in this instance, you would substitute the given variables into the inequality and solve, or you can graph the inequality and the line representing the given variable and see when they intersect with each other, okay? And we'll go over some more of these problems tomorrow, but that's basically the gist of two-variable linear inequalities. Okay. Is there any questions about anything we went over today? Okay, perfect. Okay, if there's no other questions, you guys may log off, and I will see you tomorrow for some practice problems. Bye, guys.